Hello everyone. Let us now discuss how can we solve this problem. Count elements with at least k greater values. So we are given with an integer array nums of length n and an integer k. So we are given array of length n and integer k. Okay. An element in nums is said to be qualified if there exist at least k elements in the array that are strictly greater than it. So the element is qualified, it will be qualified if there exist at least k elements in the array that are strictly greater than it. I'll take an example and explain you. Now, return an integer denoting the total number of qualified elements in nums. Now, let us take this example. Nums is equal to 312, k is equal to 1. Now, there should be at least k elements which are greater than the element, right? Okay, if I have 1, I need at least one element which is greater than 1, then this element is qualified. If I am looking at 2, I need at least one element uh, to make 2 as qualified, at least one element greater than 2 to make 2 as qualified, element 2 as qualified. Now if I have 3, I need at least one element which is greater than 3 to make element 3 as qualified. Let us check. For 1, I have two elements 2 and 3 which is greater than k. We asked for at least k. We have more than k. It is not any problem. So 1 is qualified. So the count will be 1 for now. Let us look at 2. Is there any element which is greater than 2? Yes, one element. And we also need at least k. So 2 is also qualified. Now let us look at 3. Now the count is 2, right? Now I have 3. Are there any elements which are greater than 3? No, I don't. So I'll return the answer as 2. Let us take another example where I have this 5177399258. I need at least three elements greater than current element. Let's check. Okay, now if you see, I'll be sorting this out. 1 and then 2 and then I have 3 and then I have 5 for 2 times, 5 for 2 times, and then 7 for 2 times, excuse me, and then 8 and then 9 for 2 times. Now if you see, I need three elements which are greater than the current element. For one, do I have three elements greater than the current element? Yes. So one is qualified. Okay, one is qualified. Now let's look at two. Do I have at least three elements which are greater than 2? Yes, 3, 5, and again 5. Why? Because 5 is greater than 2, 5 is greater than 2, 3 is greater than 2. We just need the total number of the elements should be greater than the current element. So it is also a qualified element. Now I have 3. I need 3 elements should be greater than 3. 5, 5, 7. Yes, 3 is also qualified. Now let's look at 5. I need three elements greater than 5. This 5 will not count. Why? Because 5 is not greater than 5. So 7, 7, 8. Yeah, I have three elements greater than 5. So it is qualified. Now again a 5. 7, 7, 8. I have three elements greater than 5. So this 5 is qualified. I have 7. Now 7 is not greater than 7, so I'll skip it. Now 8, 9, 9. I have three elements which are greater than 7, it is qualified. Now 7, 8, 9, 9. I have three elements which are greater than 7, so it is qualified. For 8, do I have three elements which are greater than 8? No, I have only two elements, so it is not qualified. And for 9, it is also not qualified. And for 9, again, it is not qualified. So how it will be if I just wrote it like 9 I am having it for 2 times, 8 I am having it for 1 time, 7 I am having it for 2 times, 5 I am having it for 2 times, 3 for once and 2 for once and then 1 for once. Now what I'll do is this element will never be our, the last number, the biggest number will never be qualified. Why? Because there are no elements greater than the element. So what I'll do is I'll just write it as remaining. For 9, it is 0. The remaining is nothing but those elements which are greater than the current element. Now for 9, it is 0. Now let's go to 8. But before going to 8, for 8, there are two elements which are greater than 8. So what I'll do before going to 8, I'll just increment the remaining to 2, right? Now I'll go to 8. For 8, I will check whether the remaining is greater than or equal to k. We need at least k, right? At least k. So what I'll check is just I will check whether the remaining elements are at least k. No, they aren't at least k. So before going to 7, what I'll do, I'll add this frequency of the element to the remaining, and it has become 3. Now I am at 7. 7 is occurring for 2 times. So for these two elements, I am checking, are there k elements after this or greater than 7? Yes. Remaining is equal to k. So these two elements, these 7 and 7, come into count. So the count will be 0 initially, and then I am incrementing with this 2, so it is 2 now. Now, before going to 5, what I will do, I'll just add this 2 to the remaining, so it will become 5. Now I am at 5, element 5, and if you see, remaining is greater than or equal to k. So what I'll do, I'll just add this 2 to the count, and this 2 I will add it to the remaining, and it has become 7. Now I'll go to 3. It is having like remaining 7, which is greater than or equal to k. So what I'll do, I'll just add this 1 to the count. Sorry, 2 plus 2 will be 4, right? 4 plus 1 is 5. Sorry for the mistake. Yeah. Then if you see, this one will also be added to the remaining, right? Then I have 8, and then I go to 2. Now if you see, they are remaining greater than or equal to k. So this one, the 2 is present for one time, so I'll increment with number 1. Now this one will also be added to the remaining. Then I have 9, right? Then I'll go to 1. Now if you see, remaining is greater than or equal to k. So I'll just add 1 to the count. Now this one will also be added to the remaining. So I got it 10, right? So totally there are 7 elements. Here also I have 7 elements. So what I'll do, I'll just take a map, right? Take a map of int comma int, right? And it will be empty. So for int num in nums, I'll just add mp of num plus plus. I'm just getting the frequency of every element. Now I have this things, right? So this I want to store it in a vector and iterate it from the back. So what I'll do, I'll just take vector of pair int comma int, and I'm naming it as v, which would be like mp dot begin comma mp dot end. No need of iterating the unordered map. Now I have the vector, right? This vector, right? And it's also sorted. That's why I use this map, right? Now I need to go from the back. So int remaining is equal to 0. Now for int I is equal to n minus 1, I is greater than or equal to 0, I plus plus. So what I'll do is, if the remaining is greater than or equal to k, then I'll just increment count with count plus what is the at this element, what are the number of elements I have for this the frequency of these elements. So that's nothing but count plus v of I dot, the second element is 1, right? Dot second, nothing but the frequency. So count is equal to count plus v of I dot second, right? Now, after this, I'll just add remaining. Remaining is equal to remaining plus v of I dot second, right? Now, that's it. We'll be returning the count at the end. Initially, the count is 0, but if you see, what if k is equal to 0? It is also a case, right? So, what if k is equal to 0? That means it doesn't matter whether there are elements greater than or uh, greater than the current element, right? So, if k is equal to 0, we'll just return the size, return n, right, where int n is equal to nums dot size. So we need to do the modular arithmetic for this thing, count plus is equal to v of I dot second. So let's look at the code. I have given the code link in the description. Go and check it. Thanks for watching this video. Please do like, share and subscribe to my channel. Thank you.